Welcome to today's lesson. Today we are going through Form 3 Mathematics under the topic Sequences and Series. But in this section, I want us to deal with arithmetic sequence, also known as arithmetic progression, before we look at the arithmetic series. I want us to look at this particular topic by considering this example, that is, consider the sequence. We have 2, 4, we have 6, 8, and so forth and so on. If you look at this particular pattern, a sequence is a pattern that is created by following a certain order. We have the first number, which is 2, and for us to get the second number, there is that common constant that is added to the first one to get the second, and the same constant added to the second, you get the third. Between 2 and 4, we have a difference of 2, and between 4 and 6, we have also a difference of 2. Between 6 and 8, also a difference of 2. That means to get the next term in this particular pattern, we are going to add third constant, which is 2, to get 10. Then from 10, we add 2, which is third constant number, to get 12. 12, you add the constant 2, you get 14. Then 14, you add 2, you are going to get 16. That means to get the second or the next term, we get it by adding that common digit or a number, which is 2. The first number that is usually given in a sequence, we call it the first term. And the first term is usually denoted by letter A. And the constant number we are adding to the first to get the second, we add it to the second to get the third. We call it the common difference. And the common difference is usually denoted by letter D. In this case now, to get the nth term, meaning the last term in a sequence, we usually take A plus n minus 1 into D, where n stands for the number of terms in a sequence. In this case now, if we can look at our sequence above, we realize that the first term, which is A, is 2, and the common difference is that constant number that we are adding to get the next number, which is 2, and n is the number of terms which we can count from this particular sequence. We have 1, 2, 3, 4, 5, 6, 7, 8, giving us our n. So from this information, we can, for example, look at the following. If we can call this example 1, and we can split the sequence above to be 2, 4, 6, 8, and for example 10. The last term in this particular sequence is 10. This 10, we call it the nth term. And we have said to get the nth term, which is the last term, we use the formula A plus n minus 1 into D. The first term is usually denoted A, and it is 2. The common difference is obtained by taking the second minus the first one, or the third minus the second, the fourth minus the third, in that order. So to get the common difference, take 4 minus 2, you get 2. And to get n, we are going to count the number of terms in this particular pattern. That is 1, 2, 3, 4, 5, and our n is 5. So how can we get 10 as our nth term? So to get 10, assuming we are looking for 10, we usually use the formula A, and our A is 2, plus we have n is 5, so 5 minus 1 you get 4, then we multiply by d, and the common difference is 2, which is going to give us 8 plus 2, which is 10. What if, for example, we have the entire of this sequence, that is 2, we have 4, we have 6, we have 8, we have 10, we have 12, we have 14, and we have 16. 16 is our last term, and the last term, which is 16, we call it the nth term. For us to get the nth term, the formula is A plus n minus 1 into D. If we can get the values of A, which is the first term, the common difference is of course 2, and n will be 1, 2, 3, 4, 5, 6, 7, 8. Our n is 8. So we are looking for 16 as our nth term by using the formula. We know A is 2 plus n is 8. 8 minus 1 you get 7. Then 7 we multiply by the common difference, which is 2. 2 times 7 you get 14 plus 2. This one will give you 16. So to get the last term in any given sequence, we use A plus n minus 1 into D. So in summary, if we are talking about the first term, that is the summary. The first term is usually denoted as A. To get the second term, we usually take A, we add D. To get the third term, it is going to be A plus twice D. The fourth term is going to be A plus thrice the common difference. How are we getting this? For example, if we are talking about the fourth term, it means this is the last term where n is going to be 4. Therefore, if we use the formula of getting the nth term, which is A plus n minus 1 into D, we are going to have A plus n is 4. 4 minus 1 you get 3. Then you multiply by D, you are going to get this one. If we are looking for example, the 10th term, the 10th term is going to be A plus simply 9D. What if we are looking for the 20th term? The 20th term is going to be equal to A plus 19D. That is, if we substitute n into the formula, we are going to get A plus 19D as our 20th term. So the next thing we are going to look at is what we call arithmetic series. When we talk about series refers to the sum of terms in a sequence. Sum of terms in a sequence. For example, let us have our previous example where we had 2, 4, 6, we have 8, we have 10, we have 12, and 14 in that particular order. In this particular example, if we are looking at a series, then these particular terms should be connected using a plus, meaning we are looking for the sum of these terms in a sequence. In this case now, if you want to find the sum of all these terms, we have 1, 2, 3, 4, 5, 6, 7. We say the sum of the 7 terms will be equal to 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14, which is going to give us 56. Instead of using the long way of making the additions, we can simply say to get the sum of any terms, we use the formula that is n divided by 2 into 2a plus n minus 1 into d, where n stands for the number of terms, a is the first term, and a d is the common difference. If we can look at the above, our first term, which is a, is 2. The common difference is 4 minus 2, or 6 minus 4, or 8 minus 6, which is 2. And the number of terms n will be 1, 2, 3, 4, 5, 6, 7. We can now get the sum of the 7 terms. And in this case, we have n, which is 7. So we take 7, we divide by 2. Into, we have 2 times a, and our a is 2, plus n, which is 7, 7 minus 1, you get 6. We multiply by the d, which is the common difference, and the common difference is 2. And this one is going to give us 3.5 into, we have 4, plus 6 times 2, you get 12, which is going to be 3.5 times 4 plus 12, you get 16, and this one is going to give us 56. So to get the sum in an arithmetic series, we simply use n over 2 into 2a plus n minus 1, you multiply by d. So for us to understand how this works, let us take a few questions so that we can understand how these particular questions are done. The first question that we have reads, given the arithmetic sequence, that is 4, 11, 18 onwards, find the common difference and the sixth term. In this case now, we have the sequence, which is 4, 11, and 18. And we have already said that the first term is denoted as a, and our first term is 4. We can now get the common difference. And to get the common difference, you simply take the second minus the first, or the third minus the second, for us to get that common difference. And in this case, to get the common difference, you can take 18 minus 11, or 11 minus 4. This one is going to give us 7. So the first part of the question A, they need the common difference, which is D, and the common difference is 7. B, we need the sixth term. The sixth term is going to be obtained by using the nth term. The nth term means, the sixth term means is the last term, which is obtained by taking A plus n minus 1, we multiply by d. In this case, if we are talking about the sixth term, it means our n is 6. We know the first term a, which is 4, and the common difference is 7. So to get the sixth term, we are going to have a, which is 4, plus sixth term means n is 6, so we are going to have 6 minus 1. Then we multiply by d, and d is 7. From here, we know this is 4, plus 6 minus 1, you get 5. Then we multiply by d, which is 7. Remember, 7 times 5, you get 35. 35 plus 4, it gives us 39 as our sixth term. Let us look at question number 2. Question number 2 reads, the 20th term of an arithmetic sequence is 60. So let us look at the solution anyway. We are told that the 20th term, and we know the 20th term will be a plus 19d, and we are told it is 60. And the 16th term, that is the 16th term, we know the 16th term is going to be equal to a plus 15d, and we are also told that it is 20. Remember, these are two simultaneous equations. This is equation 1 and this is equation number 2. We are going to solve these two simultaneously for us to get the first term, which is a, and the common difference, which is d. If I can bring them down here, we are going to have a plus 19d being equal to 60 and a plus 15d being equal to 20. Since we have a which is same, we are going to use elimination by subtracting direct, where a and a gives you a 0, so we remain with 19d minus 15d giving us 4d, and 4d is going to be equal to 60 minus 20, which gives us 40. If you divide by 4 on both sides, d is going to be equal to 10. Since we have d as 10, we can now get the value of a using equation, for example, 2. Equation 2 is a plus 15d being equal to 20. But we know we are looking for the first term. That means a plus 15d means 15 times d, and our d is 10, is going to be equal to 20. That is a plus 15 times 10 is 150 being equal to 20. If we take 150 to the other side, a is going to be equal to 20 minus 150, giving us negative 130. Therefore, we have the first term, which is a, as negative 130, and the common difference as 10, and that is the answer to this particular question. We go to question number 3. In the question number 3, we are told in the sequence, that is, we have 3, -1, -5, -9, state the common difference be the fifth term. Let us look at the solution to this question. We know for us to get the common difference in this sequence, we either take the second minus the first, or the third minus second, fourth minus third, for us to get the common difference. So if I take the second, which is -1, we minus the first one, which is 3. This one is going to give us -4 as our common difference. That is part A. Then B, the fifth term. We know the fifth term is going to be equal to A plus 4D. We have our A is the first term, which is 3. We also have the common difference, which is -4. So to get the fifth term, we only need to substitute the values of A and D in this expression. A is 3, We add 4, we multiply by the common difference, which is negative 4. This one is going to give us 3. This is positive 4. You multiply by negative 4, this one will give you negative 16. And if you take 3, you minus 16, this one is going to give us negative 13 as our fifth term. And in this case, if this is the first, this is the second, this is the third, this is the fourth, if you take negative 9, you add the common difference, which is negative 4, you are going to still get negative 13 as our fifth term. Let us look at the next question, which is question number 4. Question number 4 reads, the product of the third and the fourth terms of an arithmetic sequence is 3000. Find the first term if the common difference is 10. We know that the third term is given as a plus 2d, and the fourth term, the fourth, is given as a plus 3d, because when we are talking about the fourth term, n is going to be 4, and if we use the formula of the nth term, which is a plus n minus 1, we multiply by d, we are going to get the third and the fourth term respectively as a plus 2d and a plus 3d. We are told that the product of the two will be equal to 3000. That means if we take a plus 2d, we multiply by a plus 3d, this one is going to be equal to 3000. If we can expand the two brackets, we have a times a, which is a squared. Then a times 3d, you get 3ad. We take 2d times 2, you get 2ad. 2d times 3d, you get 6d squared. This one is going to be equal to 3000. This is a squared plus 3ad and 2ad are like terms, so we are going to have 5ad plus 6d squared being equal to 3000. But we have been told that the common difference d is 10. So if we bring back d and substitute it in our expression, we are going to remain with a squared plus, this is 5a times d, which is 10. This one is going to give us 50a plus we have d squared, which is 100. You multiply by 6, you get 600, and this one is going to be equal to 3000. So if you bring this 3000 to this other side, we are going to have a squared plus 50a minus, this is 600 minus 3000, which gives us 2400 being equal to 0. So you realize this is a quadratic equation which we can solve using any of the applicable methods, but I prefer to use formula method. And in this case, since we are looking for the value of a is going to be equal to minus b plus or minus into b squared minus 4ac, everything divided by 2a. From this expression, a is the coefficient of a squared, which is 1. B is the coefficient of the linear term, which is 50. And C is going to be equal to minus 2400. We have negative 2400. From there now we can be able to move forward. This one is going to be equal to A is equal to minus B, and our B is 50, so we are going to have minus 50 plus or minus into the square root of B squared. B is 50, so 50 squared you get 2500 minus we have 4 times A, which is 1, times C, which is negative 2400, and this one is going to give us negative 9600. Then from there everything we are going to divide it by 2 times A, and our A is 1, so this one remains A remains 2, sorry. So A is going to be equal to minus 50 plus or minus into the square root of 2500. Minus minus is plus, so this is the same as 2500 plus 9600, which gives us 12,100, everything divided by 2. We move down and have A being equal to minus 50 plus or minus the square root of 12,100 will give us 110. Then everything is going to be divided by 2. So to get the first value of A, we are going to have minus 50. We add 110, you get positive 60. 60 divided by 2, you will get 30. And the other value of A will be equal to minus 50 minus 110, giving us 160. And 160 negative you divide by 2, this one is going to give us negative 80. Then of course now you can substitute them back into this and realize or find out if the product of the two is going to give you. So in this case you substitute, we can ignore this because if you substitute it back it cannot give you a product of 3000, and therefore our first term is going to be equal to 30. We move down to question number 5. Question number 5 reads, find the number of terms in the sequence. That means we are supposed to find the value of n. We have been given the sequence, that is 3. We have 7, we have 11, and also the last term has been given as 83. That is the nth term. And we know to get the nth term, we use A plus n minus 1, you multiply by d. Since we are looking for the value of n, let us get the value of A first. The value of A is always the first term. In this case we have 3, and to get the common difference you take the second minus the first, or the third minus the second, in that order. So if you take 11 minus 7 you get 4, or 7 minus 3 you get 4, and that becomes our common difference. So to get the number of terms we need to substitute the values of A and D into the formula of getting the nth term. A is 3 plus n, we don't have n, minus 1. We multiply by d, which is 4. This one will be able to give us the nth term, which is 83. From there now, we can work out the brackets. We are going to have 3 plus n times 4, you get 4n. Then negative 1 times 4, you get negative 4. And this one is going to be equal to 83. Like terms together, we are going to take positive 3 and negative 4 to the other side. We remain with 4n. And 4n is going to be equal to 83. We add 4 because it's a negative. We also minus 3 because it is positive. Once it crosses the equal sign, it becomes a negative. So 4n is going to be equal to 83 minus 3, you get 80. You add 4. This one will give us 84. If you divide by 4 on both sides, 4 and 4 will cancel, and n, which stands for the number of terms, will be equal to 21. And that is what the question requires us to find. We move down to question number 6, where we look at now how to get the sum of terms in this particular sequence, which we call the series. So we move on and look at now the series, and in this case we are talking about what we call arithmetic series, and we have already said series simply means the sum of terms in a sequence. The question we have reads, in the arithmetic series we have 1 plus 4. Whenever you see the terms in a sequence connected by a positive or a plus sign, it means we are getting the sum of terms in that particular sequence. Find the sum of the first 10 terms and the sum of the first 100 terms. So let us look at the solution. From this sequence, we are able to get the first term, which is 1, and the common difference, which is taken by taking the second minus the first one. So if you take 4 minus 1, or 7 minus 4, or 10 minus 7, you'll get the common difference is 3. So to get the sum of the first 10 terms, it means n is going to be 10. So let us do the first part of the question. We know the sum of any terms is given by n over 2 into 2a plus n minus 1, everything multiplied by d. And in this case now, since n is 10, we want the sum of 10 terms, and this one is going to be equal to n, which is 10. So 10 divided by 2, you get 5, into, we have 2 times a is 1, so this one is going to be 2 plus, n is 10, 10 minus 1, you get 9, then we multiply by the common difference, which is 3. From here, we are going to have 5 into, we have 9 times 3, which is 27, 27 plus 2 will give us 29, and if you take 5, you multiply by 29, this one is going to be equal to 145 as the sum of the first 10 terms. Next, we look at the sum of the first 100 terms, that is part B. Part B, we need the sum of 100 terms, and we know the sum is going to be given by n divided by 2 into 2a plus n minus 1 into the common difference. Since our n is 100, so if you take 100 divided by 2, you get 50, into, we have 2 times a, and our a is 1, so we are going to remain with 2, plus n is 100, 100 minus 1, you get 99, then we multiply by the common difference, which is 3. So this one is going to be 50 into, we have 99 times 3, 99 times 3, you get 297, you add 2, giving us 299. So if you take 299, you multiply by 50, this one is going to give us 14,950 as the sum of the first 100 terms of this particular series. Question number 7 reads, the sum of the first 10 terms of an arithmetic progression, this is AP, is 400. So we know to get the sum of any terms in an arithmetic progression, we use the formula n divided by 2 into 2a plus n minus 1, everything multiplied by d. And we are told that the sum of 10 terms is 400. If the sum of the first 6 terms, that is the sum of the first 6 terms of the same series is 120, find the 15th term. So this is 120 and we are required to find the 15th term. So how do we go about this? Let us get the sum of the first 10 terms. This one is going to be equal to n is 10. 10 divided by 2 you get 5 into, we have 2a plus n is 10. So 10 minus 1 will give us 9. Then 9 times d you get 9d. And this one is going to be equal to 400. So if you move down, we are going to have 5 times 2a giving us 10a plus 5 times 9d giving us 45d, and this one is going to be equal to 400 as our equation number 1. Then we know the sum of 6 terms. That means n is 6. 6 divided by 2 you get 3 into 2a plus n is 6. 6 minus 1 you get 5. 5 times d you get 5d. And this one we are told it is 120. So if you open the brackets, we are going to have 3 times 2a giving us 6a. 3 times 5 will give us 15d, and this one is going to be equal to 120 as our equation number 2. From there now we can solve these two by use of elimination method. Let me bring them down here. We have 10a plus 45d being equal to 400. Then 6a plus 15d, this one is equal to 120. Using elimination method, let us unify this part having a by multiplying 6 into the first equation and 10 into the second equation. So if you move down through the multiplication, we are going to have 6 times 10a giving us 60a plus 6 times 45d. This one will give us 270 d being equal to 400 times 6 giving us 2400. Then 10 times 6a you get 60a plus 15d times 10 you get 150d being equal to 120 times 10 giving us 1200. Now we can subtract the two equations where 60 minus 60 would give us a 0. 270d minus 150d, this one is going to give us 120d being equal to 1200. And if you divide both sides by 120 and 120 will go such that the value of d is going to be equal to 10. Once we have the value of d, we can get the value of a, which is the first term, by substituting either in equation 1 or equation 2. So using equation 2, that is 6a plus 15d, we can substitute the value of d since we have it as 10. This one will give us 120. Having done that, now we can move and say we have 6a plus 150 being equal to 120. If we take 150 to the other side, 6a is going to be equal to 120 minus 150, giving us negative 30. So if you divide by 6 on both sides, the value of a is going to be equal to negative 5. Since we have the first term and the common difference, we can now get the 15th term. The 15th term, it means now we are going to have a plus 14d. The value of a is 5. The value of a is 5. We add 14 times d, and d is 10. This one is going to be equal to 5. Positive 14, you multiply by, this is negative 5 as our a, plus 14 times the value of d, which is 10. This is the same as negative 5. You add 140, and this one is going to be equal to positive 135 as our final answer to this particular question. Remember to subscribe to the channel if you are new, and also remember to hit the notification bell so that anytime we do a video like this, you'll automatically be notified.